In this question, it is given that 7 boys and 5 girls are to be seated around a circular table such that no two girls sits together is. You have to find the correct choice. Because the case of circular permutation creates confusion in the mind of many students. Therefore, first I will make the concept of circular permutation clear. Suppose we have to arrange 4 different things around a circle. You must be knowing that number of arrangements are 4 minus 1 factorial. And most of the students must be knowing this thing also, that minus 1 is done because we have to fix the position of one thing and remaining thing can be arranged among themselves in 4 minus 1 factorial. But it doesn't give the crystal clear idea why we have to fix the position of one thing. First, I am going to make the concept of n minus 1 factorial crystal clear. Only after that I will proceed further. I will give the explanation in 2 ways. Suppose we have to arrange 3 persons, name A, B and C, sit around a circular table. According to formula, we know that the answer will be 3 minus 1 factorial, that is 2 factorial, that is 2. But if I have to arrange these 3 persons sit in a line, number of arrangements will be 3 factorial, that is 6. The logic of this is clear to you, but the logic of this is not crystal clear to most of the students. Therefore, I am going to make proof of this formula crystal clear. Take the case of a line. If I have to arrange 3 persons sit in a line, the arrangements are ABC, BCA, CAB, ACB, CBA, BAC. For getting this arrangement, I have moved the 3 persons in this way that I have placed B here, C here and A back, and I get this arrangement. And to get this arrangement, again I have done the same thing. I moved C to this place, A to this place and B came to last place. And now these 3 arrangements are 3 different arrangements if we are speaking about the arranging them in a line. But if I am arranging them in a circle, this, the arrangement corresponding to this in circle is A, B and C. Whatever I did here, same thing I do here also. I move all the 3 persons and I get the result that A is sitting here, B is sitting here and C is sitting here. Now again move the position of all the 3 persons by one more place. I will get C here, A here and B here. This is the arrangement corresponding to this linear arrangement. This is the arrangement corresponding to this linear arrangement. This is the arrangement corresponding to this linear arrangement. But these 3 arrangements which are corresponding to these linear arrangements are not different, they are same. These 3 arrangements are different, but these 3 arrangements are same. On what basis? The basis of my argument is, actually when we are looking at the arrangement, we are just looking at the table and the 3 persons. Nothing else is visible to us. Think like that this is a table in space and these are the 3 persons around a table and you are looking at this table. Suppose for some time you go away and come back. Suppose these 3 persons have arrange now in this way, will we ever able to say that they have changed their position? You will never be able to say that they have changed their position because nothing else is visible to us. Actually, the three arrangements in a line are giving rise to only one arrangement in a circle. That is, I mean to say, corresponding to every three arrangement in a line, I will be getting only one arrangement in a circle. Hence, if 3 vertical were the number of arrangement in the case of line, then number of arrangement in the case of circle will become 3 vertical upon 3, that is 2 vertical. In general, if there were n things, in the case of linear arrangements, number of arrangement will be n vertical. But if I have to arrange those n things around a circle, number of arrangements will be n vertical upon n, that is n minus 1 vertical. To make you clear, take the example of 4 persons. Okay. Now suppose the 4 persons are A, B, C, D, B, C, D, A, C, D, A, B, D, A, B, C. These 4 different elements in a line will give rise to only one arrangement in a circle. Therefore, if we are dealing with 4 persons, number of linear arrangements will be 4 vertical, but number of circular permutation will become 4 vertical upon 4, that is 3 vertical. Still, if somebody has not got the crystal clear idea, now this argument will make it crystal clear. To derive the formula of n minus 1 vertical, I can prove in this way also. For simplicity, I am taking the example of 4 persons A, B, C, D. To prove the formula 4 minus 1 vertical, in the case of 4 persons sit in a circle, I can prove in this way also that A, this is one possible arrangement. I fix the position of one person. I don't change the position of this person. And now, out of remaining, if anyone changes its position, it will be clearly visible to us because I can see his position with respect to A. Suppose B comes here, C comes here, and D comes here, it will be clearly visible to us that they have changed their position. And it is not required to fix the position of one person if in the question it is given that this is a circular table and this table is broken somewhere here. It is a mark at this position on this table. And now for such a table, if I have to arrange 4 persons sit around this circle, number of arrangement will not become 4 minus 1. Now it will be 4 vertical only, because I can always easily check the position of any persons with respect to this mark. Means something is there with respect to which I can check the position of others. In that case, minus 1 will not come. Then in that case, 4 vertical will be the answer. Or suppose the question is this, that arrange the 4 persons around this circle. In how many ways we can arrange these 4 persons? But the extra thing given to us in this question is, there is a wall here. And now I say arrange the 4 persons around this circle. In that case, now the number of arrangements will not be 3 vertical, it will be 4 vertical only, because with respect to wall, it will be clearly visible to us that the persons have changed their position. By now you must have understood the reason of minus 1 factorial. Before I do the question now, one more simple question I will do, and then I will come to this question. Suppose the question is there are 5 boys and 5 girls, and we have to make them sit around a circle such that boys and girls are always alternate. To find the number of arrangements, first let us make boys sit around this circle. For boys, the number of ways of arranging will become 5 minus 1 factorial, that is 4 factorial. Suppose boys are B1, B2, B3, B4 and B5. But when I'm going to arrange the girls, suppose the girls are G1, G2, G3, G4 and G5. These are the girls. In the case of girls, number of arrangements will be 5 factorial only. In the case of girls, minus 1 factorial will not come, because once boys are already sitting, then if girls change their position by one place, it will be clearly visible to us that girls have changed their position, because boys are already sitting. With respect to boys, will be able to see that girls have changed their position. Therefore, in the case of girls, 5 factorial will be there. Therefore, total number of arrangements will become 4 factorial into 5 factorial. And now come to the question. In this question, it is given that 7 boys and 5 girls are to be seated around a circular table such that no 2 girls sit together is. You have to find the correct choice. First, I will make 7 boys sit around a circular table. For 7 boys, number of arrangement will become 7 minus 1 factorial, that is 6 factorial. Suppose the boys are B1, B2, B3 up to B7. We have made them sit around a circle. And once boys have sit, now I require to make girls sit so that no 2 girls are together. Clearly, there are 7 possible positions where the girls can sit. This. These are the 7 possible positions where the girls can sit. Because there are only 5 girls, to make them sit, first I will choose 5 positions for making the girls sit. And once I have chosen 5 positions, I can make girls sit at those 5 positions in, because boys are already sitting. Therefore, total number of ways will become 7 minus 1 factorial into 75 into 5 factorial, that is 6 factorial, into 7 into 6 by 2 into 1 into 5 factorial. So far I have got the answer 7 into 6 by 2 into 1 into 6 factorial into 5 factorial, and this is equal to 6 into 5 factorial into 7 into 6 into 5 factorial by 2. Clearly this is equal to 126 into 5 factorial square. Hence I can say first choice is the correct choice.